Swayam Prabha. Digital India. Educated India.
Next, we will move on to the next case where we are loading only about one of the principal axis V. Okay. In this case again, let's first go from back now. The stress will be given by, in this case, the stress or the moment that will be produced is only mu moment. Okay. The moment produces a mu moment, that will be P into x for 0 less than x less than L by 2, P by 2 into x, and it will be P by 2 to L minus x for bending moment in the region L by 2 less than x less than L. Okay. Now then from the bending equation you have E d square delta V by dx square is equal to mu by iuu. Okay. So basically now, and your stress sigma xx would be mu by iuu into V minus V naught. Okay. Where V naught is the position of the CG of the cross section along the V. Since we assume that the centroid and the origin of the coordinate system coincide, this V naught would be 0. Okay. So this will be given by this expression in here. Okay. So let's again look at what kind of stresses are produced at L. What kind of stresses are produced at L, M and N. Okay. Now clearly there is loading only along one direction. The neutral axis is the U axis, U axis. Okay. So basically now because of this force you can feel that M would be in tension. Okay. L would be in compression. So thus N also will be in compression because the point N is above the U axis. It's in the negative V direction. Okay. It's in the negative V direction. Okay. So basically from here you conclude that L and N are in compression and M is in tension in this case. Okay. And again to find delta V you have to use the same relationship that we found before, and you will find that delta V at L by 2 is again given by PL cube by E iuu into 1 by 48. Okay, in this case. Okay, that is along the delta V direction. Since this displacement is not along y or z, in this case also there will be a y and z displacement, but the y and z displacement would be delta y would be delta V by root 2 with a negative sign, and delta z would be delta V by root 2. Again resolving the V displacement to y and z directions. That is, you have a displacement, this is y and this is z. You add a displacement along this direction which is delta V at an angle of 45 degrees. So if I resolve this along z, it will be delta V by 42, and along y it will be minus delta V by cos 45, sin 45. Okay, that is 1 by root 2. Okay, so the relationship between delta V, delta z and delta y is given by these relationships. Okay, so now what you have seen is the deflection will be confined to a particular plane only when the plane coincides with the principal axis of the cross section. The plane doesn't coincide with the loading plane doesn't coincide with the principal axis of the cross section, then there will be deflection in more than one direction, and you have to be able to compute what these deflections are from simple equation that we derived in the last lecture. Okay, as an illustration we use the angle section to get these expressions. Okay, thank you.